Hello, I'm Mr. Troha. We're going to be doing some astronomy notes about stars and specifically the beginning stage of the stars. So here we have a picture of the life cycle of stars. Notice that all of our stars are starting as stellar nebula. That's gas and dust, cosmic dust, that eventually gravity pulls that dust together and it forms a star. Now, notice there are two paths. There's the top path and the bottom path. And the main difference of whether a star travels on the top path or the bottom path is how much mass it has. The top are average stars, the bottom is a more massive star. Today we'll be talking about up to the red giant stage. Now, in the beginning, we had just cosmic dust, a lot of subatomic particles and things that were forming together. Everything was very hot, and it took a long time, in fact, 400,000 years after the Big Bang before hydrogen it cooled off enough that subatomic particles could come together to form hydrogen atoms. Now, all those hydrogen atoms, not very exciting. But what happened? Gravity happens, and as you get hydrogen atoms, which are not very massive, but they did pull each other together, and that hydrogen started to form a star. So 400 billion years later, these hydrogen atoms formed together enough to create a star and allowed it to start some fusion. Yes, this sucker is nuclear. If you have not seen Back to the Future, go for it. Do that during your break. Nuclear fusion, we talked about this last week. This is what's happening in our sun and in stars. The proton-proton chain pulls these hydrogens together, and eventually we get helium out of it, but along the way it produces energy. If you remember, those hydrogen atoms lose mass when they form together. During this process, the two singular things have mass. When they combine into one, actually some of the mass is lost and turned into energy. That energy then comes to us in the form of protons. Now, how long does this last for a star? Well, it kind of depends on the star. The bigger, more massive, brighter, hotter burning stars, these blue supergiants, they might only last a couple million, 100 million years. But red dwarfs, which are cooler and do not burn quite as hot and as fast, they last for trillions of years. Ours is right in the middle. Our sun has been around for about 5 billion years, and it should be going for about 5 billion more. It's in middle age. So why are stars the way they are? Well, there's this constant battle. You have all of this mass, and all this mass is trying to pull itself together. The gravitational attraction is trying to pull everything into a single point. But as it pulls together, it gets hotter, and that fusion happens. And during that fusion, it's like these atomic bombs going off, and so they're trying to force all the mass away. So it's this constant battle, this equilibrium between pulling together with gravity and exploding apart from the fusion. Eventually, though, this battle has to be doesn't just continue forever. It might take many millions or billions of years, but eventually the hydrogen runs out. The hydrogen has been formed into helium, and we no longer have hydrogen fusion. When that happens, there aren't as many as explosions pushing it out, so the gravity starts to win. It starts to pull it together. But as it pulls together, it heats up. It heats up and hot enough that now the helium can fuse together. And when helium does that, it creates even larger explosions. More energy is provided compared to the hydrogen, and it has such a great outward force that the size of the star increases. The gravity no longer wins at that point, and it gets much bigger. That is how we get our red giants. So we talked about how we have the gas and dust formed hydrogen. Those hydrogen atoms came together, ultimately had stars that had fusion, and as the hydrogen dies and we start forming helium, that's where we start seeing the red giants. I'm going to leave you here with some fun pictures of the sun. I particularly like the one down here in the bottom left. I think that's hilarious. All right, you guys have a great week.